Hello, students. I am Kazim Naqvi from Center for Information Technology, Jamia Millia Islamia. Today, I am going to introduce you to an important topic called operating system. In this topic, I shall be introducing to what operating system is, what are its function, why is it required, what are the types of operating systems, and then towards the end, we shall be discussing Windows and Linux operating systems. So, operating system is a system software which is responsible for providing all kinds of facilities to the user or enable him or her to work on the system. Now, this software manages all the hardware resources which a computer has, and it provides some kind of interface to the user with which the user is able to interact with the computer and perform various functions which they want to, without going into the complexities of how hardware is working, how are the hardware components are coordinating with each other, right? So, in case if you see this figure, you can see that the inside circle represents hardware, which is the core, a computer system. Now, in case if I directly want to use hardware, it is not possible for me. I cannot talk to the hardware directly. To enable me, talk to the hardware, this layer of system software, which we are referring to as operating system, has been introduced. So, this layer is responsible for managing all hardware components, as I said earlier, of the hardware. Now, above this layer, there is one more layer of software which we refer to as application layer. So, application layer is providing us, with number of software which we can use for performing specific application. You might have heard of applications such as MS Office or maybe Internet Explorer, Google Chrome. So, they are all running at the application level, right? So, these application level software in turn talk to the operating system, and operating system and talk to the hardware and gets the job done. So, in this way, it is something which is enabling us to get our job done without getting into the complexities. So, popular operating system which are available on most of the computers these days are Windows, Linux, Mac operating system, and even on mobile devices you have operating system which we normally refer to as Android, and the variations of operating system. So, as you can see that operating system is an essential component to work on a computer system. Now, an operating system allows a user to effectively use the hardware resources by providing features such as user interface. Now, when I say user interface, when you boot a computer system, you always get some kind of screen to work with. You are able to move your mouse, you are able to click on icons, you are able to recognize applications by their iconic presence, and you can click them and those applications get started. So, basically user interface is something which is providing all these elements to a user, which is enabling him to interact with the system without facing much problem. So, this is called user interface. So, it is the responsibility of operating system to provide a good user interface to the user so that he or she is able to understand the system and able to perform the work. Then user management. One computer system may be utilized by a number of users. So, it is the responsibility of operating system to let the administrator of the system create user accounts on it, and all users are able to get their work done from their respective accounts. So operating system will authenticate them the moment they try to log into the system. For example, it would ask them their logins and passwords, and once this authentication is done, operating system would enable them access the system. So this leads to another point called security. Fine. So user authentication is an example of a security which operating system is providing to the user. In addition, operating system provides a firewall, for example, to prevent intrusion into the system. It will restrict traffic from coming or going outside the system. Similarly, it will provide protection to the file by making the files read only, so that nobody can modify them. Only authorized users are able to change their contents. By making you hide the files in case if you don't want the files to be visible. So these kind of security features are also provided by the operating system. Then an important or rather the core part of it is the resource management. As I said earlier, that operating system is managing the hardware resources, and to manage these hardware resources, it does number of things which are required. The first thing is called the process management. Then you have CPU management, memory management, file management, and I/O management. So let us see what process management is. So whenever you execute a program on an operating system, the moment it starts running, we start calling it as a process, right? So it is the operating system that makes that program which was residing on the hard disk of your computer system turn into something which is now running. An example is MS Word may be on your computer, but unless and until you double click on the icon, it will not start running. So the file which is containing MS Word program as such, software as such, can be referred to as a program. But the moment I double click it, it becomes active. It is now running. It starts running, and who makes it run? It is the operating system. So operating system will load the instructions contained in those in the program into the memory of the computer system. It will now invoke the processor, and processor will read the instructions one by one and start executing them as as per the logic of that program. So a running instance of a program is referred to as a process. So a process has context space which comprises complete information about the process, including process ID, process state, I/O state, CPU registers, CPU scheduling, etc. So without going into the complexities, you can just take note of the various states in which a process can be at any point of time. So initially the process is newly created. The moment you double click on an icon, the program starts running. So the process state is new at this point of time. The moment it starts running, the state changes to ready, or rather when process is ready for execution, the state is ready, and when it starts running, the state changes to run. And at some point of time, for example, the program or the process might want something from the user. For example, some kind of input is required to be entered from the keyboard. So at that moment, the processor need not run that program. So it will be stopped temporarily. It will be blocked temporarily, right? So the process now enters into a state which we refer to as wait state or the block state, wherein the user is typing in something from the keyboard. Right. So at this moment, the processor is not doing anything, or rather you can say that the processor is now free to execute something else. So in case if our operating system is intelligent enough, it would realize the change of this state and can use the processor elsewhere in doing something else. Right. So that would make the entire system more optimized or more efficient. Once the process completes running, it is set to be completed, right? Or the process is terminated and it need not be in memory now. So it has to be removed from the memory. Similarly, when the ready queue is full, the process enters into the suspended ready queue. And similarly, when waiting queue becomes full, some processes are moved to the suspended block state. So all these activities, of changing the states, is the responsibility of the operating system. So operating system would, sense these stages and can take, action so as to control the hardware and make the entire setup, an optimized one, an efficient one. So this diagram actually, shows the same thing. So initially, for example, the process is in ready state. So when it gets into the running state, the upper circle shows that to you it is now running, and after running the program may also enter into the termination state, or that it gets terminated. So a running process, in case if suppose some keyboard input is required, will now be blocked, so it enters into the blocked state. And similarly, when that input has been provided by the user, it will again be ready for execution, and operating system will assign it to the processor as soon as possible, so that the same program move forwards. So these states would keep on changing depending on what user is doing, if he or she is providing the input, or the processor doesn't, or the process doesn't need any kind of input and it can be run, or depending on other aspects. For example, how important the program is, it would be prioritized by the operating system, right? So it is the responsibility of operating system to manage the resources, assignment of the process to processor, loading of program into memory. So all this stuff would be done by the operating system for you. The next is memory management. So as I told you earlier, that a program has to be loaded into memory for execution. So this memory is the one which is being referred to here is called the primary memory, which we also call as RAM of a computer system, right? So because that RAM is limited in amount, it is expensive memory, so it cannot be too much in the system. So it always has some limitations. So RAM is limited, and because of limited size of the RAM, so the operating system has to use it judiciously. So for example, if a program cannot fit into the main memory, it will move some part of that program onto the hard disk, right? And whenever that part of the memory is required, that memory would again be swept back into the main memory. So this kind of thing is to be done by the operating system, so that all processes which are running, they have their memory contents available to them all the time, so that the program can be completely executed without any problem. So in a sense, memory is limited in amount. It has to be utilized judiciously. All running processes need access to the memory, and therefore operating system needs to manage it. Similarly, you have features such as file management, wherein a user create a file, and this time we are talking about the secondary storage or the hard disk of the computer system. So files are to be created, they are to be stored. User will be performing various operations on the file. For example, they would delete the file at any point of time, so that part of the storage disk may get free. But somebody has to make a note of it, that this part is free, and should make use of that the moment new file is to be created, right? And similarly, the file may increase in size, the file may decrease in the size. So the space on the hard disk is dynamic, right? It will at some point of time a file may occupy more space. The same file may after some time may shrink to a lesser size. So the changes which are happening in size are freeing up the space, or they are occupying more space. So all these operations which makes use of the space efficiently is referred to as file management. Again, it is the responsibility of the operating system. So as users, we are not supposed to think about the complexities which are involved in managing processes, in managing CPU, in scheduling CPU, in managing memory of the operating system, or in managing the files. Similarly, keyboard is an input device. You have the display as your output device, or the printer is an output device. So all kind of these devices are also to be managed, right? They need to be sent the data for processing, or they need to provide data to the system. So again, this requires some kind of interfacing, some kind of complexities involved, some kind of hardware devices needs to be managed. So this part again is the responsibility of the operating system, and this is referred to as I/O management. So these are the basic functions which an operating system, any operating system would provide for you. Now next is the types of operating systems. So operating systems have been evolving since 1950s, late 50s, and till now, right? So initially we were having very primitive systems, and now we have systems which are running on cloud as well. We have clusters, we have virtual machines, and all those new concepts have come up. So all machines are running on some kind of operating system. Now So this slides actually list various types of operating systems. So we start with batch, then we have multiprogramming, multitasking, multiprocessing, multithreading, and so on and so forth. So let us see what these are in the coming up slides. So batch systems, they are very primitive systems used in late 60s, and the idea behind batch system was to manage the operating system in more efficient manner. Earlier days, people used to take one program punched in form of cards, and then those cards were loaded into trays, and then computer used to execute them. Again, it used to make output. Then output, unless and until that output is ready, the system cannot execute anything because it was not having anything actually. So new set of cards would be provided, would be loaded into the computer, and only then it will start executing. So it leads to lots of wastage in terms of the resources. So what people thought was to have batches of jobs ready for execution, and this led to the development of batch system. So the idea behind the batch system was to collect a tray full of jobs in the input room and then read them into a magnetic tape. So the jobs were read into the magnetic tapes, and magnetic tapes were then mounted on a tape drive. The operator then loaded a special program which we can now refer to as operating system, and this program used to read the first job from the tape and ran it. The output was written onto a second tape. After each job finished, the operating system automatically read the next job from the tape and began running it. When the whole batch was done, the operator removed the input and output tape and replaced the input tape with the next batch. The output tape was used for printing the output offline. So this setup was more efficient in the sense that multiple jobs were getting executed one by one, and this lead to the wastage. This lead to minimization in the wastage of time, which were required to earlier load the new job into the system. So a batch was given, batch was comprising of various jobs, and the batch was completed, only then the next batch was loaded. Then you have the concept of multiprogramming evolved. Multiprogramming is the ability of an operating system to have multiple programs in memory at once. While one program is waiting for the I/O, the other program is run by the CPU. So in the previous diagram, I showed you that when a process is running and suddenly it expects something from the user, right? So the process would be blocked. Now the process is blocked. Essentially, now I am providing something from my keyboard now. So at this moment, CPU is ideal. It is not doing anything. Fine. So operating system, in case if it is a multi-programming operating system, it would sense the opportunity that processor right now is free because the first program is actually reading something from the user. So can I use this time to run another program? So if operating system is capable of doing this kind of thing, we call it as a multi-programming operating system. So as you would realize that the wastage of CPU has been minimized, because the moment one process is not directly making use of CPU, another program, another process is being executed by it. So the concept is known as multi-programming. Then you have a single tasking and multitasking operating system. So as clear from the name, single tasking operating system can only run one task at a time. So for example, a DOS. Multitasking operating system can execute multiple tasks or program by assigning each task to the processor for some duration of time. So you may see it in a form that multiple programs are available. So you keep all, say 5 programs want to run. So you take all 5 programs, maybe for initial 1 microsecond you are devoting yourself to the first program. In the next microsecond you are devoting yourself to the second program, and that way, so what you are essentially doing, you are dividing your time amongst all 5 programs one by one, amongst all 5 processes one by one. So this is also referred to as time sharing. So because this is happening so fast that people would just see that all programs are running simultaneously, while the processor in this case essentially is spending little time on each process one by one, and that way all processes are actually running. But the processor is running one task, at one time effectively. But the user sees it that all 5 tasks are running parallelly. So this is known as the time sharing, capacity or utility of the operating system. So Unix, Linux, and Windows are all examples of multitasking operating system, while MS-DOS used to be, a single tasking system. So if a program is running, it was not possible, for us to execute another program. Then you have multiprocessing and multi-threading system. So multiprocessing is essentially the ability of an operating system to execute more than one process simultaneously on a multiprocessor machine. So this is important, that now we have the concept of multiprocessor being introduced. So the computer is capable of running more than one CPU, right? So in case if you want to have a serious server available in your maybe office or maybe in your for your work, so they can do more work for you because you have more than one processor. So in case if you have such a setup where more than one processor is available, the ability of operating system to execute more than one process simultaneously is referred to as multiprocessing setup. Then you have another term which is referred to as multi-threading, is the ability of an operating system to execute the different parts of a program called threads at the same time. Threads are the lightweight processes which are independent part of a program or a process. In multi-threading system, more than one thread are executed parallelly on a single CPU. Then you have a single user operating system and multi-user operating system. So as clear from their name, single user operating system would only allow one user to work on it at any point of time, while multi-user operating system would allow multiple users to work on the operating system at any point of time, right? So MS-DOS used to be an example of a single user operating system, and Windows, Unix, Linux, so they all are example of multi-user operating system. So they can allow multiple users to work on the system at any point of time. Then you have embedded operating system. So as clear from the name, they are embedded in some device, right? So embedded operating systems are designed to be used in embedded computer systems. They are designed to operate on small machines with less autonomy. For example, personal digital assistants. They are very compact and extremely efficient by design because they are running on very small devices. So obviously they will not have too much of power inside them. There is limited battery, so they cannot use too much of resources, or they cannot be too extravagant in terms of using the resources. So such operating systems which can run on these small devices are referred to as embedded operating system, and examples are Windows CE and Minix. Then we talked about user interface part of the operating system. So these days, all operating systems provide two kinds of interfaces. One is called the graphical user interfaces, and the other one is called the character user interface. The graphical user interface, as clear from its name, is graphical, right? You would be able to see things in form of pictures, in form of graphics. Windows, for example, is an operating system which provides everything in form of graphics to you, right? Similarly, you have character user interface, where you would not be able to see the graphics part of it. Rather, you would be interacting with the operating system with the help of commands. Windows does provide both the interfaces. Similarly, you have Linux. It also provides both interfaces. So all operating systems which are available today, they are providing both kind of interfaces: graphical user interface as well as character user interface. So it is seen that the more technical users are comfortable with CUI part of it, while the users who are non-technical prefer the GUI part of it, right? This slide summarizes, how Windows operating system has evolved over a period of time. So Windows operating system was first seen in 1985, and the version which was released at that point of time is referred to as Windows 1.0. And this actually was not an operating system. It was more of an MS-DOS utility. So first of all, you need to boot your system into MS-DOS mode, which was a character user interface, CUI. And then from there you used to execute a command, and that command would launch this application which they refer to as Windows 1.0. So not many people know about Windows 1.0, and it was not at all effective in terms of appealing users at that point of time. Windows 3.x, which evolved during 90 to 92, is the more familiar version of Windows, and it broke the 1 MB memory barrier at that point of time, and it was a 16-bit operating system. Windows 95, which is referred to as Windows version 4, was the first operating system which was 32-bit, and it booted a computer system. So earlier we used to require MS-DOS, and from MS-DOS we used to load Windows. Windows 95 directly can boot, was able to boot the computer system, and without need of installing MS-DOS on it. Then you had another version which became quite popular called Windows 98. It was more of an upgrade to 95, and it tightly integrated Internet Explorer with the operating system. Then Windows ME was released in 2000, which was again an upgrade to Windows 98. Then Windows NT, which was both client and server versions were released, and it was again a 32-bit operating system. Windows 2000, which is referred to as version 5, it was an update on Windows NT 4.0 and introduced plug and play features, Active Directory, and then there were client and server versions available. Windows XP is one of the most popular versions of Windows ever since, right? And it enhanced the security and admin capabilities. Windows Vista, it did not become popular because of its bugs, and it is known for the bugs rather. So it was more of an embarrassment for Microsoft, but they quickly came up with Windows 7 in 2009, and again it became quite popular and a very stable operating system. Then Windows 8 was released in during 2012 to 2013. So it came with client version, featured desktop tablet integration, replaced start menu with start screen. So the move towards mobile devices also started, right? Because earlier interfaces were desktop interface and mobile interface. Now they tried to integrate the tablet features into the operating system. And then the current version of Windows is Windows 10, and so it is still evolving, and in future you would have more improvements coming up on Windows. Linux is again a very popular development in area of operating systems. It was developed by a person called Linus Torvalds in 1991. It is an open operating system, and that makes it different from the others. Windows, for example, is a proprietary product of Microsoft, right? While Linux is something which is in open source, right? So the source code is available, and people can download it, can install it on their computers without paying anything, right? Though commercial versions of Linux are also available. So because of this openness, it has a large community of users who got attracted towards it. Some were downloading it because it was free and it was good, and the others were contributing to the development of the operating system. So it is relatively more secure in comparison to Windows. There are fewer known instances of malware on Linux. So for example, you would not find many viruses which are targeting the Linux users. The reasons being that maybe Windows has more number of users at this point of time, and the way operating system has been built. Fine. So in terms of the security, we consider Linux to be better than Windows. Then Linux is used on variety of machines and applications. It is used for desktop applications, embedded systems, and server applications. It is used on range of machines from wristwatches to supercomputers, maybe on your phones, your laptops, your PCs, even in your cars, and even in your refrigerators. Linux is working somewhere. So it is becoming very popular in terms of its spread and use. It provides a variety of free development tools, again a reason for its popularity, which makes it popular amongst developer communities. I can write any kind of software on Linux, various compilers, and other tools are available, and because of because of the open source concept with which it has come up, number of tools are available, and I don't need to pay anything, and that is a major reason for its popularity. Now Linux parts are developed by different people, right? For example, kernel may be developed by a company, right? Somebody may develop the shell utility, somebody may write the graphical user interface. Fine. So different people are developing their own, part of the Linux operating system. So Linux can be availed from various sources, which are referred to as Linux distribution, list, or more popularly as distros. So some of the popular distros are Ubuntu, Mint, Debian, CentOS, Red Hat, and Fedora. So out of these, Red Hat is a commercial variant of Linux. So it comes with all Linux features, but in addition, you can have support in case if you get stuck into any problem. You can log a complaint with Red Hat and they would be able to assist you in finding out what the problem is. So for that, you need to pay Red Hat some amount, right? The other variations are free. You can freely download them and you can install them on your system. Now quickly, in case you want to work with Windows, so you need to be familiar with these elements. Every Windows operating system will have some kind of desktop. It will have a start menu, taskbar, search, control panel, file explorer, Cortana, which is a digital assistant available on Windows, right? So in case if you are familiar with these, you would be able to work with Windows operating system. So in case if you open up Windows operating system, you would be seeing this kind of interface. So here you have the start menu on the left bottom of the screen. Adjacent to it, you have the search button. So if you want to search anything inside your computer system, you can type in there and Windows will try to find out that resource for you. Adjacent to it, on the right side, you have Cortana. The Cortana is a digital assistant wherein you can say something. You can using your voice, and using your voice, Cortana will try to find out that resource from your computer system. Then you have File Explorer. So File Explorer essentially is a place where all files and directories would get stored. So all your resources, either they can be in form of installed software, or they can be in form of your files which you have created over a period of time. You can find using File Explorer. The taskbar is the bottom black bar which you are seeing on the screen, and this taskbar shows the tasks which are running, and something in case if you want to make very frequent use of it, you can pin certain tasks, certain programs on the taskbar as well. So all running applications are shown here. On the desktop, you can place icons, and these icons can be clicked at any point of time and they would start running. So this is the interface. This is the graphical user interface part of the Windows, and so you can see that this all is available in form of graphics. You can understand it, you can click it, and so the interface is not very difficult to work with. Control panel is an important component of Windows, wherein all hardware related thing or maybe the software related thing can be managed and administered. So it contains features such as system and security, network and internet. So what to do in case if you want to connect your computer to network or internet, again it is the responsibility of the operating system. So how to do it? You get into this part of it and it will let you give IP addresses, subnet mask, default gateway, etc., etc. Then you have hardware resources. So you may want to find out what my machine hardware is, how to configure in hardware, how to install drivers for it, for example. The next part is the programs. So you can install a software, you can remove a software, you can create user accounts on it. Fine. So all these low-level component which require direct interfacing with the Windows administration part of it can be handled using the control panel, which is again a part of the operating system. Linux operating system, I have just shown you a slide of Ubuntu desktop. And as you can see that over a period of time, it has also started providing good interface. Initially, it was a drawback. User interface was not very good. We used to have more of a character user interface because it was meant to be used by technical users initially. But of late, Linux has started providing impressive desktops in form of GUI, and people are able to make use of this GUI in doing the things as they do it on Windows. So that is also making it popular because the difficulty part in accessing the system, in using the system, is now also diminishing over a period of time. So with this, we have come to an end. So I hope in this session you have learned about operating system. You know how to now define operating system, what are the main functions which operating system provides, what are the types of operating systems, how Windows has evolved over a period of time, and what are the important elements of interface of an operating system. In the end, I have just introduced you to the interface part of the operating system. I hope you have enjoyed the session and you have learned something about it.